Welcome back everyone. Today's topic for the discussion is Introduction to Universal Mobile Telecommunications System UMTS. As part of the agenda, let us look at the key objectives of UMTS to start with. Then we will see the various frequency bands that are licensed to be operated by UMTS networks, and then we'll discuss on additional services that are offered by UMTS networks in addition to previous generation mobile system, that is GSM. And then we'll continue our discussion on high level network architecture, which enables offering these additional services to UMTS mobile subscribers. And finally we'll conclude the discussion by looking at key security considerations. As part of Introduction to 3GPP Technologies video, we have seen various 3GPP technologies such as GSM, Global System for Mobile Communications, UMTS, Universal Mobile Telecommunications System, LTE, Long-Term Evolution, and 5G, and how they are advancing the world of mobile communications. Let us continue our discussion on one other 3GPP technology, that is UMTS, Universal Mobile Telecommunications System, which is considered as third generation mobile technology of 3GPP variant. In case if you have not yet watched the video on Introduction to GSM, Global System for Mobile Communications, I highly recommend to do that for continuity. Now, when it comes to UMTS objectives, which are aligned with the requirements set up by ITU, International Telecommunications Union, as part of IMT 2000. To start with, integration of mobile services, that is, UMTS should provide a wide range of telecommunications services to mobile users globally. UMTS to provide these services through a flexible, modular service creation environment, which also allows service providers to differentiate their service offerings. Next is choice of mobile station and service, that is, users to be able to find a mobile station which has particular functionality they require and to obtain the set of services they want from a single source, thereby satisfying all their mobile telecommunications needs with a single mobile station, subscription, and billing arrangement. Users will be free to own one or more mobile stations and to obtain a mix of services from several service providers if they wish. Then terminal flexibility, which means UMTS mobile stations should be flexible and adaptive in order to support different air interfaces and to provide functionality for telecommunication services. Then global terminal mobility, which means UMTS to support global terminal mobility, that is global roaming. Then speech quality, that is UMTS has an objective of speech quality comparable to the fixed network wherever it is practical. Then satellite coverage. Satellites will provide access to UMTS where the terrestrial component is not available or when satellite access is selected by the user or the network operator. Then MMI and mass market. The man to machine interface for mobile stations will be defined to achieve a good balance between two essential requirements, that is basic functions will be standardized in order to meet the needs of a mass market for easy handling and for applications like emergency calls. Then when it comes to UMTS Spectrum, it is an objective of UMTS to exploit the frequency bands identified as part of ITU 2000 recommendations. And then when it comes to high bit rate services, UMTS to provide high bit rate services up to initially 2 megabits per second. Control of theft, fraud and abuse. The structure of UMTS and its telecommunications services should minimize the opportunity for fraud and theft of mobile stations and facilitate its prosecution. Security, ensuring that information generated by or relating to a UMTS user or subscriber is adequately protected against misuse or misappropriation. It is also necessary to ensure that the resources and services provided by a UMTS service provider or network operator are adequately protected against misuse. Then migration and evolution. To allow a cost-effective introduction of UMTS, a migration path to exist, whereby portions of existing systems and networks may be exploited for the implementation of UMTS. Furthermore, UMTS shall allow the easy introduction of technology advancements and service applications without undue impact on existing users and terminal equipment. The last one is mobile station type approval. In order to facilitate global terminal mobility, it is an important objective that mobile station type approval made in one country or region should be accepted in other countries or regions. When it comes to support of frequency bands or spectrum ranges, there are multiple frequency bands that are identified for the operation of UMTS. UMTS supports two modes of operations, that is FDD, frequency division duplex mode, wherein uplink and downlink transmissions use two separate frequencies as in the case of previous generation mobile system, that is GSM, while TDD, time division duplex mode, uses same radio frequency for both uplink and downlink communications but at different time intervals. When it comes to telecommunication services offered by UMTS, all the services that are available in GSM, that is basic telecommunication services including bearer and tele services along with supplementary services and network features are supported in UMTS. In addition to these services, UMTS offers additional features as mentioned here. Let us look at a very high level description of these features. This is not a deep dive discussion on these individual features in this video. This is to socialize the various features offered by UMTS similar to the way we did during our GSM discussion. To start with, personalization of mobile equipment. Personalization features work by storing information in the mobile equipment which limits the identity modules with which it will operate. There are 5 personalization categories which include network personalization allows a mobile equipment to be personalized to a particular network, for example, to prevent the use of stolen mobile equipments on other networks. Then network subset personalization is a refinement of network personalization which allows network operators to limit the usage of mobile equipment to a well-defined subset of identity modules. Then service provider personalization, which allows a service provider to associate a mobile equipment with the service provider. Corporate personalization is a refinement of service provider personalization which allows companies to prevent the use of mobile equipments they provide for their employees or customers with other identity modules without that corporate personalization. SIM USIM personalization, which is an anti-theft feature. When a mobile equipment is SIM or USIM personalized for a particular SIM, it will refuse to operate with any other SIM or USIM. Hence, if the mobile equipment is stolen, the thief will not be able to use it with another SIM or USIM. Then mobile station application execution environment. It provides a standardized execution environment in an user equipment or mobile station and an ability to negotiate its supported capabilities with a service provider, allowing applications to be developed independently of any user equipment or mobile station platform. Next, noise suppression for AMR codec. This is an optional feature designed to enhance speech quality in a range of environments where there is a significant background noise. Virtual home environment. The concept of VHE is that users are consistently presented with the same personalized features, user interface customization, and services in whatever network and whatever terminal wherever the user may be located. Virtual home environment is an important portability concept of the 3G mobile systems. It enables end users to bring with them their personal service environment while roaming between networks and also being independent of terminal used. Then open service access. In order to be able to implement future applications or end user services that are not yet known today, a highly flexible framework for services is required. The aim of open service access is to provide a standardized, extensible and scalable interface that allows for inclusion of new functionality in the network in future releases with a minimum impact on the applications using the open service access interface. Multimedia messaging service MMS. The MMS will allow users to send and receive messages exploiting the whole array of media types available today, such as text, images, audio, video, while also making it possible to support new content types as they become popular. Multimedia technology is rapidly developing new capabilities such as multimedia messages, games, presentations, and services that are now considered to be part of everyday life. The next feature is presence service. The presence service results in presence information of a user and information on a user's devices, services, and service components being managed by the network. The presence service provides access to presence information to be made available to other users or services. Then multimedia broadcast multicast service MBMS. The multimedia broadcast multicast service is a unidirectional point to multi-point bearer service in which data is transmitted from a single source entity to multiple recipients. The next service is push service. It introduces a means to transmit push data from a push initiator to a push recipient without a previous user action. In the normal client server model, a client requests a service or information from a server, which then responds in transmitting information to the client. This is known as the pull technology. The user pulls information from the content provider. The World Wide Web is a typical example of pull technology, where a user enters a URL, that is the request, that is sent to a server, and server answers by sending a web page, the response to the user. In contrast to this, there is also the push technology, where there is no explicit request from the user before the content provider initiates an information transfer to a user. Another way of saying this is that whereas pull transaction of information are always initiated from the user, push transactions are content provider initiated. The welcome message received after registration with a visitor network while roaming is an example of information transfer that has been initiated without a request from the user. Then we have global text telephony, GTT, which is a text telephone systems were implemented mainly for distant conversation with deaf, hard of hearing, speech impaired and deaf blind users. The text telephone systems offer a real-time character by character conversion in text, optionally combinable with voice. Global text telephony is a feature that adds the capability to use a text conversation component in a session. One important reason to offer the global text feature is to enable emergency service access to people who are depending on a written dialogue. Then the next major feature, IP Multimedia Subsystem, IMS. IP has opened up a whole range of communication applications which may allow operators to develop totally new value-added applications as well as to enhance their existing solutions. The open architecture and platforms supported by IP and operating systems may lead to applications and new opportunities that are more difficult to replicate using a standard switched centralized solution. A complete solution for the support of IP multimedia applications, including voice communications, to be available. One of the main objectives for 3GPP specifications is to ensure that the availability and behavior of these IP applications when used via the 3GPP mobile access is at least as good as when used via other mobile access types. Then transparent end-to-end packet switch streaming service. 3G mobile systems, through the increase in available bandwidth, offer new possibilities and services. One of these new services will be the ability to stream sound and movies to mobile devices. Then comes 3GPP system to wireless LAN area network WLAN interworking. The growth of public wireless local area networks provides an opportunity for appropriately equipped user equipments to access HPLMNs and visited PLMNs via wireless local area networks. Then comes 3GPP generic user profile. The fact of having several domains within the 3GPP mobile system, example circuit switched, packet switched IP multimedia subsystem, and access technologies such as GRAN, UTRAN, and WLAN introduces a wide distribution of data associated with the user. Further, the new functions both in terminals and networks means that the data related to users, services, and user equipment will be increased greatly. This causes difficulties for users, subscribers, network operators, and value-added service providers to create, access, and manage the user-related data located in different entities. The objective of specifying the 3GPP generic user profile is to provide a means to enable harmonized usage of the user related information originating from different entities. Technically, the 3GPP generic user profile provides an architecture, data description, and interface with mechanisms to handle the data. Then comes digital rights management, which enables the consumption by users of protected content by allowing content providers to express permissions. Then comes speech recognition framework for automated voice services. A 3GPP speech recognition framework enables the use of conventional codecs to distribute in the network the speech engines that process speech input or generate speech output. Then comes personal network management, which allows the users to manage their devices and personal networks. Now let us look at the various domains that UMTS supports. UMTS to support a wide range of applications with different quality of service profiles. Hence, a modular approach is considered in defining the network parts of UMTS. The modular approach should also make UMTS possible to implement efficiently in different network environments. Let us look at the basic domains of UMTS. User equipment domain. It is the equipment used by the user to access UMTS services. User equipment has a radio interface to the infrastructure. This domain encompasses a variety of equipment types with different levels of functionality. User equipment may include a removable smart card that may be used in different user equipment types. The user equipment is further subdivided into the mobile equipment domain and the UMTS subscriber identity module domain USIM. The mobile equipment performs radio transmission and contains applications. The mobile equipment may be further subdivided into several entities. Example, the one which performs the radio transmission and related functions, which is mobile termination MT, and the one which contains the end-to-end application, which is terminal equipment. The USIM contains data and procedures which unambiguously and securely identify itself. These functions are typically embedded in a standalone smart card. This device is associated to a given user and as such allows to identify this user regardless of the mobile equipment used. Next comes infrastructure domain. The infrastructure domain is further split into the access network domain and the core network domain. The access network domain consists of the physical entities which manage the resources of the access network and provides the user with a mechanism to access the core network domain. The core network domain consists of the physical entities which provide support for the network features and telecommunication services. The support provided includes functionality such as the management of user location information, control of network features and services, the transfer mechanisms for signaling, and for user generated information. The core network domain is subdivided into serving network domain, the home network domain, and the transit network domain. The serving network domain is responsible for routing calls and transport user data or information from source to destination. It has the ability to interact with the home domain to cater for user specific data or services, and with the transit domain for non-user specific data and services purposes. The home network domain represents the core network functions that are conducted at a permanent location regardless of the location of the user's access point. The home network domain therefore contains at least permanently user specific data and is responsible for management of subscription information. The transit network domain is the core network part located in the communication path between the serving network domain and the remote party. Now let us look at high level architecture of UMTS. Starting with user equipment, which is used to be called as mobile station in GSM. User equipment consists of the physical equipment used by UMTS subscriber. It comprises the mobile equipment and the subscriber identity module called UMTS Subscriber Identity Module USIM. The mobile equipment comprises the mobile termination, which depending on the application and services may support various combinations of terminal adapter and terminal equipment functional groups. Then radio network system RNS. It is the system of base station equipments including transceivers and controllers, which is viewed by the MSC or SGSN through a single interface as being the entity responsible for communicating with mobile stations in certain area. The RNS consists of one radio network controller and one or more node Bs. A radio network controller is a network component that controls of one or more node Bs. A node B is a logical network component which serves one or more cells. Then comes core network. The core network is logically divided into circuit switch domain, a packet switch domain, and an IP multimedia subsystem. The circuit switch domain refers to the set of all the core network entities offering circuit switch type of connection for user traffic, as well as all the entities supporting the related signaling. A circuit switch type of connection is a connection for which dedicated network resources are allocated at the connection establishment and released at the connection release. The entities specific to the circuit switch domain are MSC, Mobile Services Switching Center, MSS, MSC Server, Circuit Switched Media Gateway, CSMGW, and Interworking Function IWF. The Mobile Services Switching Center MSC constitutes the interface between the radio system and the fixed networks. The MSC performs all necessary functions in order to handle the circuit switch services to and from the mobile stations. The Mobile Services Switching Center is an exchange which performs all the switching on signaling functions for mobile stations located in a geographical area designated as the MSC area. When needed, the MSC can be implemented in two different entities: the MSC server MSS, which handles only signaling, and the media gateway handling users' data. MSC server mainly comprises the call control and mobility control parts of IMSC. MSC server controls the parts of the call state that pertain to connection control for media channels in a circuit switched media gateway CSMGW. The circuit switched media gateway interacts with media gateway control function MSC server and GMSC for resource control, and also handles resources such as echo cancellers and others. The interworking function IWF provides the functionality necessary to allow interworking between a PLMN and a fixed networks such as ISDN or PSTN. Then we have a packet switch domain, refers to the set of all the core network entities offering packet switch type of connection for user traffic as well as the entities supporting the related signaling. A packet switch type of connection transports the user information using autonomous concatenation of bits called packets. Each packet can be routed independently from the previous one. The entities specific to packet switch domain are the gateway GPRS support node GGSN and serving GPRS support node SGSN. The GPRS support nodes perform all necessary functions in order to handle the packet transmission to and from the mobile stations. SGSN stores two types of subscriber data needed to handle originating and terminating packet data transfer. GGSN stores subscriber data received from the HLR and the SGSN. The border gateway is a gateway between a UMTS networks supporting GPRS and an external inter-PLMN backbone network used to interconnect with other UMTS networks also supporting GPRS. The role of the border gateway is to provide the appropriate level of security to protect the UMTS networks and its subscribers. Then IP Multimedia Subsystem IMS, which comprises all core network elements for provision of IP multimedia services comprising audio, video, text, chat, etc., and a combination of them delivered over the packet switch domain. The entities specific to IP multimedia domain are call session control function CSCF, media gateway control function MGCF, IMS media gateway control function IMS MGW, media resource function MRF, breakout gateway control function BGCF, application server AS, interconnection border control function IBCF, and location retrieval function LRF. Starting with call session control function, which can act as proxy CSCF, serving CSCF, emergency CSCF, or interrogating CSCF. The proxy call session control function is the first contact point for the user equipment within the IP multimedia subsystem. The serving call session control function actually handles the session states in the network. The emergency call session control function handles certain aspects of emergency sessions, such as routing an emergency request to the correct emergency center. The interrogating call session control function is mainly the contact point within an operator's network for all IMS connections destined to a subscriber of that network operator or a roaming subscriber currently located within that network operator's service area. The Media Gateway Control Function MGCF, which controls the parts of the call state that pertain to connection control for media channels in an IMS media gateway. It performs protocol conversion between ISDN user part ISUP and the IP Multimedia subsystem call control protocols. IMS media gateway may terminate bearer channels from a switched circuit network and media streams from a packet network. IMS media gateway may support media conversion, bearer control, and payload processing. It interacts with the media gateway control function for resource control. It also handles resources such as echo cancellers. Then the media resource function control, which controls media stream resources in media function resource processor. It interprets information coming from an application server and a serving call session control function and controls a media resource function process accordingly, and it also generates CDRs, call detail records. Then the media resource function processor provides resources to the control by the media resources function controller. It mixes incoming media streams. It also sources media streams. It processes media streams, and it also controls the flow messages. The breakout gateway control function BGCF selects the network in which circuit switch breakout is to occur, and within the network where the breakout is to occur selects the MGCF media gateway control function. Then comes an application server, that is SIP application server or Open Service Access Application Server or CAML IMSSF, which offers value added IP multimedia services and resides either in the user's home network or in a third party location. Then comes an interconnection border control function IBCF, which provides application specific functions at the session initiation protocol, session description protocol layer in order to perform interconnection between two operated domains. Then the last one, the location retrieval function LRF, which retrieves location information for the user equipment including where required, interim location information, initial location, and updated location information. So entries that are common to both circuit switched and packet switched domains are the home subscriber server HSS. It is the master database for a given user. It is the entity containing the subscription related information to support the network entities actually handling calls or sessions. A home network may contain one or several home subscriber servers. It depends on the number of mobile subscribers, on the capacity of the equipment, and on the organization of the network. HLR can be considered a subset of the home subscriber server. Authentication center can be considered as a subset of the home subscriber server HSS. The visitor location register VLR contains the information needed to handle the calls setup or received by the mobile stations registered in its database. VLR also contains supplementary service parameters attached to the mobile subscriber and received from the HLR. The Equipment Identity Register EIR in the UMTS system is the logical entity which is responsible for storing in the network the international mobile equipment identities IMEIs used in the UMTS system. The mobile equipment may be classified as whitelisted, grey-listed, and blacklisted, and therefore may be stored in 3 separate lists. An equipment identity register shall as a minimum contain a whitelist. Then we have the subscription locator function SLF is queried by the interrogating call session control function during the registration and session setup to get the name of the home subscriber server containing the required subscriber specific data. Furthermore, the SLF is also queried by serving call session control function during the registration. It is also queried by the application server in conjunction with the SH interface operation to get the name of the HSS containing the required subscriber specific data. SLF is not required in a single HSS environment. Now when it comes to security aspects, the radio interface between the terminal equipment and the serving network represents a significant point of attack in 3G. The threats associated with attacks on the radio interface are split into unauthorized access to data, threats to integrity, denial of service, and unauthorized access to services. Hence, it is imperative to provide a stronger security in UMTS, that is 3G, than the previous generations of technologies. There are three key principles behind 3G security. 3G security will build on the security of second generation systems. Security elements within GSM and other second generation systems that are proved to be needed and robust shall be adopted for 3G security. 3G security will improve on the security of second generation systems. 3G security will address and correct real and perceived weaknesses in second generation systems. 3G security will offer new security features and will secure new services that are offered by third generation mobile system 3G. Now let us also look at 3G security objectives. That is, ensure that information generated by or relating to a user is adequately protected against misuse. Ensure that the resources and services provided by serving networks and home network environments are adequately protected against misuse. Ensure that security features standardized or compatible with worldwide availability. Ensuring that security features are adequately standardized to ensure worldwide interoperability and roaming between different serving networks. Also ensuring that the level of protection afforded to users and providers of services is better than that provided in contemporary fixed and mobile networks including GSM. Also ensure that the implementation of 3GPP security features and mechanisms can be extended and enhanced as required by new threats and services. Thank you so much for your time. I hope you find this information useful and interesting. Please feel free to subscribe as we continue our discussions on remaining 3GPP technologies, that is LTE, long-term evolution, and 5G.